let's see what you came up with. Select the equation represented by the 100 square grid, and we're going to start with number 1 here. Okay, so anybody want to offer up which equation you think it is, and might give me some reasoning for it? Besides, wait,
B.
you think it's B, okay? So let me circle that one just for now, just to see if we can agree with that, okay? So give me some reasoning, Wade, why you chose that one.
Well, because you have 90 covered up, and each section is divided by thirds.
Each section is divided by thirds?
Into thirds.
Okay, so that whole section of 90 is divided into thirds, you mean? Okay, so the whole section of 90, so you're talking about this to start with, right? The whole section of 90, that's the shaded part. Is everybody shaded? 90 of them shaded? And you're saying that's divided into thirds. So there's 1, 2, 3 parts. Okay? So does this say 90 hundredths? How much is in each part?
30.
How many is it? In each of those 3 parts, how many squares are there? 30. So what, if there's 30 shaded squares, what's that? What decimal is that? What's 30 shaded squares?
0.3.
Okay. What was it before it became 0.3? What was it before? What is it before it becomes 0.3? Because I don't see 3/10 on here right now. I am seeing 30 hundredths on here right now. No, I can't deal with you right now. Okay, so Wade's equation says 9/10 divided by 3/10. I want to know how, I don't see tenths right now. Does anybody else see tenths? So convince me why it's 9/10 divided by 3/10. Danny? Yeah, they crossed the 0 out. They cleaned it up, didn't they? Would it be this to start with, you guys? Would it be that to start with? Write that in the margin next to that one. That's what it starts as, doesn't it? Before they cleaned up those zeros. So this is really saying how many times can you take 30 squares out of this 100 square grid out of 90, you can take them out 3 times. So that makes sense, doesn't it? Okay, how about number 2? How about number 2? Which equation what's going on in that one? How many squares, first of all, are shaded? Caden?
40.
40 of them. Okay, so we have, this is the shaded region right here, right? 40 squares are shaded. Okay, so how would we represent that as a decimal? What would that look like as a decimal?
40 hundredths.
40 hundredths. Okay, well, all of these say 4/10, don't they? Is 4/10 the same as 40 hundredths? Yes, it is. Okay. Well then, now what? Which one's it going to be then? Because they're all 4/10, so that's not going to help us now. We need some more. Kate?
A.
You think it's A? Okay. So in other words, we have two sections of 20 hundredths that we can take out of there. Is that what's going on? 2 sections of 20 hundredths being taken out? If there was, where would there be a line? Wouldn't that be right there? Is there a line there? Wouldn't this be 40 hundredths divided? See how many times you can take 20 hundredths out?
Yes.
Okay, so we can't, it's not going to be A. Sorry, we're going to have to say no to A. Can't be that one. Danny? B. Okay, so that one says we have 40 hundredths. How many times can you take 10 hundredths out? And so that would be, if we're going to do 10 of them, that would be like this. A whole column is 10. So that would be, this would be 40 hundredths divided by 10 hundredths, and we get 4. Are those lines in there that I just put in? Are they in there? I don't think so. So we got to get those out. I got to get mine out of there. They're not really there. They weren't there. The only thing that's there is this right here. This is 40 hundredths. What's being divided out of it? 40 hundredths. It's being divided by itself. That's what's going on here. It's being divided by itself. And notice right here, we have a 1 for an answer. There's one section out of our shaded region. Okay, so that's representing a decimal being divided by itself. What happens when you divide any number by itself?
Turns into 0.
No,
Or 1.
1. Any number divided by itself is always 1. Always 1. Okay, let's go to number 3. Okay, what's happening in number 3? Which equation should we go with? Well, first of all, how many of the squares are shaded to start with? 50. Half of it, right? 50? Okay. How many squares are in each of these sections here? Because we got this, and then we got this. So this is section 1, this is section 2. How many are there in each of them? Kaylee? Count for me, because I don't want to count. Okay, hands up those of you who want to answer. Kaylee, look up and pick on somebody to answer for you then. Pick somebody to answer for you. Who? Caden? Okay, Caden. There's 25 squares, so that's 25 hundredths. So we really have here 0 and 50 hundredths being divided by 0 and 25 hundredths. How many times can we take 25 hundredths out of 50 hundredths? And we get 1, 2, right? So which one is it? A. Answer A is that one. Okay. And number 4. Danny? Which one? A. Okay, she says A. Let's see if she's right. Okay, in this one, I see that this is our big region. This is what we're dividing into. We're saying how many things can we take out of it. And then I am seeing this on my paper. Am I right? So 1, 2, 3, 4, 5, 6. This says 3. Can it be that one? It says equals 3, but we got 6 of them. Sierra?
C.
It's going to possibly be C. Let's check. How about that one instead? So 60 hundredths, because there's 60 squares shaded. It's divided into how many squares in one region? How many? 10. So that's 10 hundredths. And what can we do with those zeros that are on there? Cross them off. And we're supposed to get 6. That's this one, isn't it? Yeah. Let's talk about money again. Tell me what that says in money. Tell me what that says in money. Kakia?
60 cents divided by 10 cents.
Yeah, 60 cents divided by 10 cents. How many times can you take 10 cents out of 60 cents? How many times can you, Sylvia? 10. I don't think so, but when you're done with your magic, you're teaching me how to do it, okay? 60 cents divided by 10 cents. Let's do it in dimes. 60 cents is how many dimes? 6. 10 cents is? How many dimes? How many dimes? Yes, it's 1. How many times can you take 1 dime out of 6 dimes? 6 times. There are 6 dimes and 60 cents with 6. Yeah, with 6. Okay. So again, we have to make sure what this is supposed to be helping us do is make sure that we understand the reasoning behind dividing. Okay? We aren't going to want to have to draw pictures like this all the time, though, are we? But we should be able to have an understanding of what's going on. So notice what's happening. We are taking decimal numbers less than 1. Whenever we are dividing a decimal number divided by another decimal number, we're getting a number greater than 1, aren't we? Okay, let's go to the back side of that page, or is it just over to the next page? I'm not sure which one it is. Okay. We have a, what's this called?
Scatter plot.
Scatter plot. We have a scatter plot. what we're going to do, and you won't be doing any of this in your homework, I don't believe, today, but we're going to practice it right now. We're going to be working what's called the line of best fit. So in this particular scatter plot, we're comparing how loud the radio is to the number of correct answers. Let's see. 20 questions about the radio. Oh, so it's there was an experiment going on. Students were given 5 minutes to read a short story. Then they were given 20 questions about the reading. The volume of the radio played at different levels, from 0 silent to 10 very loud. So when the volume of the radio was at 0, what happened? When somebody had the radio at silent, what happened? How did they do on the questions from their reading? How many did they get correct? Well, it's right here. Right there. So we have a couple of people represented there. One of them got 17 of them correct, and the other one got 18 correct. Well, who did the worst?
17.
Of the whole scatter plot now. Who did the worst on the whole scatter plot? When the volume was what? When the volume was 4, we got these people who they scored 11 and 13. Okay. So what's happening here? Is this a direct relationship or an indirect? Well, first of all, is there even a relationship? Is there a relationship?
Yeah.
Are those points going in a pattern? Yeah, they kind of look like they're going in a pattern to me. So there's a relationship going on. Tell me then now, is it a direct relationship or an indirect? Is it a direct relationship or an indirect? I did give you these rulers to distract you right now. I gave you these rulers because we're going to use them in a little bit. Right now, the question is this. We've already decided there's a relationship. Is it an indirect relationship or a direct relationship? Everybody needs to have an answer because you're going to take a vote. I'm taking a vote. You gotta vote. Okay, you ready? How many of you think it's an indirect relationship? Direct relationship. Okay. Well, I think Kelia and or Sylvia, you better convince all these other people in the majority why it's a direct relationship. Okay? Can you convince them? Can either of you convince them? No one? Can you convince these other 11 people in here why it's a direct relationship when they say it's an indirect? Okay. I want you to because they're the majority and I want you to change the majority. Okay, she can't, or she's not understanding what I want her to do. You guys convince them then. Somebody convince them why it's an indirect relationship. Why is it indirect? Wait, why is it indirect?
Because the dots are all over the place.
No, it's not because the dots are all over the place. That's what I taught you the first time. I had to reteach you, remember? Cheyenne. Yeah, one of them is increasing, so as the volume of the radio goes up, the number of questions correct goes down. So this is an indirect relationship. You know what? Guess what? They gave it away up here. Where did I see it at? I saw it. I know I did. It's especially hard to read. This is an indirect relationship right here. Will you circle that? This is an example of an indirect relationship. So that means our line of best fit should be going down from left to right on this graph. So here's what we do when we pick where the line of best fit should go. We try to put it through the middle of the pattern in a good location that has about as many points on one side as it does on the other. Your line cannot go through all the points when they're scattered like they are, right? So what we're going to do is you're going to take your ruler and you're going to try and play around a little bit and see where do you think it would go through about the middle of those points. It might touch some of them, it might not touch all of them, it might not touch any of them. You have to make a decision what looks like would be a good location for about the middle to draw a line of best fit. after you've done it, will you just kind of do a quick count and say, how many points do I have above and how many points do I have below? So like I'm gonna count and I have that, you know, like it's not touching at all. I have 3 on this side, I have about 3 on that side. So I think I have a good spot for mine. How'd you do? So if you want to copy mine, you can. If you're like, I'm just not really sure where to put it, just feel free to look up and say, kind of, where did she put it in there? So a line of best fit is just kind of like something that we can make predictions off of now. In fact, we're going to make a prediction really quick here. You know, some people really like the radio loud. And they think they can multitask, they're like, it helps me. This scatter plot would disprove that, wouldn't it? So tell me, about how many questions correct would somebody get if they had the volume at 7? Look on mine right here, let's look at mine. What would we do to make a prediction how many questions we think they would get correct if they had the volume at 7? Danny, what should we do? I'm sorry, what? About 4 correct? Okay, well, don't we have to go to 7 right here? And then follow, you do this on yours, and then follow it up to the line, and then kind of like make a mark right there, and then follow it across and see how many correct would they get. This is just a prediction. So with my line of best fit, I am predicting that the person would get between 7 and 8 correct. What about yours? Did you get 4? Is it more than 4? So lines of best fit help us make predictions based on the relationship we see going on. That's the line helps us show that relationship. Okay? Okay, so what I want you to do is I want you to close your workbooks up. You're not going to have to put more in. You can just leave them on your table for me. Put your ruler on top of your workbook.